I've been 3D printing pretty regularly for a couple of years now. I started almost 20 years ago, but the tech was pretty bad, and it took a long time for the printers and filaments to get to the point where they are today, where you can pretty reliably print things with a dozen different materials. It was always cheap, but until recently it wasn't very good. Metal 3D printing is the opposite. It's been pretty good for a while, but it's never been cheap. But now, it kind of is. I've had friends telling me to get things 3D printed out of metal for about a year now, and I haven't because I don't like change. No, it's because I haven't really designed anything that would be better suited for that manufacturing process, and also I don't like change. But with the new engine going in the car, there are a few things that would make life easier if they could be made out of printed metal. I talked about a few of these things already. The first were these Y fittings I made for my heat exchanger stack. I could probably make these with some welded aluminum or some fittings screwed together, but this felt like a pretty good first test. And they came out great. A little heavier wall thickness than I need, but that was my fault. Overall, excellent solution. About a dozen other parts later, and I wish I would have just made the entire heat exchanger stack out of one large metal 3D print. It would have been better, and it probably would have cost less. Metal 3D printing is surprisingly cheap these days. Cheap enough to use on your own project. I know some of you used metal 3D printing years ago, and so did I. I once got a prototype door hinge done that looks similar to this. It cost over $2,000. You can get it today for about 80 bucks. There are two big differences between the metal 3D prints I'm talking about today and the plastic 3D prints littering my garage. The first is how they are made. The plastic parts are made by squeezing out a filament of plastic through a heated nozzle that moves around on a bed that slowly moves down and stacks up layers. The metal 3D prints are made with lasers. The machine lays out a thin layer of very fine, very consistent metal powder, and then a high-power laser melts one layer at a time. At the end of the plastic print, you just take your part out of the printer, but at the end of the metal print, you have to vacuum out all the extra powder, and the powder can be both explosive and bad to breathe. There are metal printers that work like your home plastic 3D printer, and there are plastic printers that use powder, but that's not what I'm using, so I'm not going to talk about that today. The other difference is the plastic 3D printer is in my house. It's affordable and small, and I own one. 3, actually. The metal 3D printer is in a building somewhere far away, owned by some company that I pay to do the printing for me. There are some similarities between the pooping string and the powder bed. You need to use support material in both cases. With the plastic printer, you get pretty good at orienting things in a way that don't give you problems when cleaning it up. With the metal, you have less control over where it goes, but generally if you can print in plastic with minimal support material, you can print in metal with minimal support material. The parts don't always come out perfect from either process. Holes will be slightly smaller and flanges will distort. I find the plastic to be a little bit better at maintaining its shape, but it does depend on the geometry and the filament. I've had a few parts made and I've kind of been pushing the limits to see what can be done. I'll start with the simple stuff and move to more complex. We'll start with those F fittings. I made these out of both stainless and aluminum. The stainless ones were about 70 bucks and the aluminum was 60. Shipping and tax brought the total for all three of them to about 250 bucks. You can see on this one where it looks like support material was removed, still the geometry is good. Everything seems to be accurate to within less than 10 thousandths of an inch, which is totally fine for these, although all of the openings are ovaled a little bit. The thinner you go, the more deformation you're going to get, and I went way thick on these walls. You could kill a man with this thing. These fittings could actually be made out of plastic. They are on the cold side of the heat exchanger. Stainless is way overkill. They should be aluminum with half the wall thickness. Still, this was a perfect use for metal 3D printing. Pricing on printing is highly correlated with the mass of the part, which makes sense because more mass is more material and more laser time. So if you are good at designing things that are not overkill, you can probably make something like this better and cheaper than you could make it most other ways. The throttle body I'm using has this groove cut in it that looks like it would be great for an OEM molded rubber connection, but I want to use a silicone hose with a simple bead connection. I looked around and you can buy a CNC milled adapter made for the size hose I'm using. There are a few different companies that make these. I bought one and measured it and put it in CAD for packaging, and I realized that this middle flange here connecting the two sides is less than 10 thousandths of an inch. That's about 1/4 of a millimeter. I felt like this is way too thin. I did some basic math on it and it will hold up to my boost pressure at high temperatures with a decent factor of safety, but it just looks too thin. So I returned this. I looked at getting it custom CNC machined, which would have been about 300 bucks, but I ended up getting it 3D printed out of aluminum for $80. That was the total price after shipping and import duties. I did change this in 3 places. I added material in these 3 spots. I did this so that I could chuck it up in my lathe and get a nice smooth surface for sealing. I have an O-ring that goes in here and the silicone hose that seals up here. But once I got the part, I realized I didn't need to do that. The surface is not perfect, but it's more than smooth enough to seal air for a turbocharger. If I did this again, I'd just get it 3D printed as the final shape and spend about 10 minutes with sandpaper to smooth it out. I'd be less inclined to trust this if it were sealing pressurized fluids like fuel or oil, but even then I think you could probably spend some time with sandpaper and get a smooth enough surface for an O-ring seal. Again, this was an excellent choice for metal 3D printing. I talked about this one in a previous video. This is my fuel pump hanger, and it is great. I welded this together with some stainless steel tube, and this is one of the nice things about 3D printed metal. It welds super easy, which makes sense because that's kind of how these parts are made. I have heard that if you get your parts sandblasted, the sand will stick in the metal and mess up your welds. Everything I got has been glass bead blasted, and I've had no problems welding. I got pretty small with the text on the top here, and it still printed out just fine, totally legible. These parts all together were $240 after shipping and taxes. I had this part made to hold my fire bottles on, pretty simple. It came out great, $80 shipped to my door. I could have made this for less money with a piece of angle, but at this point I was just adding stuff to the cart to see how it came out. This is an excellent part for metal 3D printing. This is my exhaust manifold. This was $700 total cost, which seems like a lot, but if you've ever tried to make an exhaust header, you know that the merge collectors, bends, and flanges all add up real quick. I bet I would have spent close to this making it the old-fashioned way, and it would have been worse. The smooth curves and tight packaging would be so difficult, if not impossible, with welded tubes. I know the flow to my wastegate isn't that great, and that means I might get boost creep. Some of you already went to the comments to point this out, but please keep in mind this channel is called Superfast Matt, not Wastegate Priority Matt. If you want to know how I designed this, I did pretty much exactly what Couchbuilt did over on his channel, and I'll link that video in the description. He has some other good videos on metal 3D printing you should check out if you're interested in this. I welded on the flanges for the turbo and wastegate, as well as threaded ports for the exhaust temperature sensors, because I wanted to make sure those are all geometrically very accurate. I also had it ceramic coated for heat. By the way, I went really heavy on the wall thickness because I don't want this to be a problem. It's 4 millimeters. I probably could have done 2, and if I did, it would have been a lot less expensive. So far, I've gotten all my prints through CraftCloud. They're not sponsoring this channel or video. I have no relationship with them except as a customer. CraftCloud does not make your part. They give you a list of companies that can do it for you, along with the price and location, almost always in China. I've had the best luck with 3DP NXT. They have the best quality and best communication on possible problems. The most complicated part I've had printed out of metal so far is my intake. I added a lot of complexity and detail to this print, partly just to see what I could and couldn't get away with on these prints. Overall, it's pretty awesome. The cool thing about 3D printing is that you can fit a bunch of features without much extra effort. This has ports for 8 injectors, mounting holes for the rails, ports for water injection, intake sensors that has bell mouths, a place for a fuel pressure regulator. It even has a feature to help constrain the fuel line. It all came out pretty good. It's not perfect. You can see straight away that the surface finish is pretty bad. The inside has a lot of roughness, partly from support material, but you can also see some areas where it looks like they had to maybe weld in some repair. It's pretty rough in some places. I added this waffle webbing to the bottom to add some stiffness, and you can see that there's a little flashing and bits left stuck in a lot of places. The flange that the intercooler attaches to is visibly not flat. This part here is bent. Also, the holes for the injectors are not smooth enough to seal around the injector O-rings. I expected this part, which is why I undersized the injector holes to be drilled out later and added material to the flange to be milled off. I'm not super happy with the surface finish, especially on the inside, but the other problems were expected, and overall, I'm pretty impressed with this part given its complexity. It was kind of expensive, about $1,000 all in. I added my logo to the top with incredibly thin detail, and they did email me before they started printing to tell me that it wouldn't show up, but I asked them to continue anyway just so I could see how it did, and I'm pretty impressed with the fact that it got most of it in there. Some of these parts needed post-processing, but none as much as the intake. The first thing I did was spray paint it, since it will need some corrosion protection. You might have noticed my ears sticking off the sides here. I added those to help with post-processing, specifically milling the 2 mating flanges flat and drilling the injector holes. The different flat sides are to grab with a toe clamp on the mill. I have access to a mill, so I'm going to use it, mostly because I hate sanding, but you can probably use a belt sander and sanding discs to accomplish the same thing with good enough results. To locate the intake in the right orientation, I used old-fashioned plastic 3D printing to make fixtures that cradle the intake. Then I clamped down on the ears and cut the mating surfaces smooth. Milling a flat surface on here definitely highlighted the fact that this part is not entirely dimensionally accurate. You can't see it that well in the video, but after one pass, it's obvious that this flange is warped up in the middle and down on the outsides. It's also obvious after I finished and there is still paint on the outside corners. I didn't measure it, but I'd guess about 40 thousandths of an inch, so not insignificant. I plastic printed a drill guide to help me center the drill in the injector holes, and that did jack squat to help. I'm using a stepped drill bit that gives me the exact shape I need for the injectors. I left about 1 millimeter of extra material to be drilled off, and that was just barely enough. I had to eyeball the center of the drill and then start the cut and then check how centered it looked and then adjust. If I were to do this again, I'd make the pilot hole way smaller and then just let the drill bit do most of the work. Another interesting thing to note here is that the injector ports are supposed to be exactly 80 millimeters apart from each other, but the holes are about 79.8, so over the entire span of the intake, it shrank about half a millimeter, or about 20 thousandths of an inch. Basically, you have to think about 3D prints like castings. If you have critical geometry, you're going to have to either weld on a machined part or post-process it somehow. Like I said, in a lot of cases, you can probably get away with sanding these surfaces if you're careful. I still think plastic is pretty awesome, and it is a great solution for most things, but some things just need to be metal. And while I have a machine in my house that poops out plastic parts, the metal printing machines are all outside my house. Most of them very far outside. Most of this stuff comes from China. You can get things printed in Europe or North America for a premium. People lament all this manufacturing going to China, but if you've ever tried to get things manufactured in the US, you know a lot of places don't even want to talk to you unless you have a $100,000 PO for a military contract. Places like Send Cut Send have changed this for laser cutting and CNC, but with 3D metal printing, you can pay China half as much to get it done twice as fast, and the communication is usually better. Shipping is pretty fast, but never as fast as they say. You can expect to wait about 3 weeks to get your parts to your doorstep, even if they tell you it will be sooner. These dates are always optimistic. The strength is also a bit of a variable. I made all my parts a lot thicker than they need to be. With CNC parts, you can usually assume isotropic material with known material strength, but with printed parts, you can visually see places where the material didn't print consistently and layer lines where the machine either stopped or shifted. If I was doing something like a suspension part, I would definitely figure out a way to do a static load test on a bench to double check the strength before using the part. All my parts had some distortion. The circles had pretty accurate circumference, but they were ovaled by some amount. Flanges were angled up or down, and whole parts shrank by measurable amounts. Keep this in mind when you're designing your parts and think about how you're going to fix the inevitable distortions. Support material does affect quality, leaving ugly parts, and you do have to sometimes go in with a pick and remove some support left in there. The more complex a part is, the bigger this problem is. There are levels to building things. You can piece together pre-made kits, you can modify existing things, or you could build things from the ground up, but you're never really getting to the base level of creation. You're not making your own bolts, and even if you are, you didn't smelt the steel. And even if you did, you didn't create the iron from nuclear fusion inside the core of a star. Unless you did, in which case, hit me up, we should be friends. You're always starting at some level of complete and moving up from there. I love making things. I love designing and creating things that didn't exist before. So it always feels weird when I move up a level. Like I previously would have made an exhaust from raw metal, and aside from some simple welds, I didn't really do anything to this. It just showed up at my door. But the cool thing about starting out on the next level is that you can reach a lot higher. These parts are all better than they would have been if I made them in my garage, and I think the car will be better because of it. It will be faster. It better be, because all of this is taking a lot of time and money. This type of stuff leans a lot more on the design side than the fabrication side, and that's also cool because it opens up possibilities for a lot more people who don't have expensive machines and time to learn how to use them. You can make a lot more things and you can reach a lot higher. It kind of feels like we're living in the future, and that's pretty cool. I live a very diverse life. I build cars, I write about cars, I make videos about cars, I drive cars, all sorts of completely different things. Still, I tend to forget about things like grocery shopping and leaving the house. Fortunately, today's sponsor, Factor, will deliver fresh, chef-crafted and dietitian-approved meals straight to my doorstep. No planning, no cooking, no stress, easy cleanup. Heat, eat, done in 2 minutes. I like it because I can easily eat healthy and quickly and get back to the safety and comfort of the garage. There are over 100 rotating weekly options, meals, salads, breakfasts, shakes, all built for nutrition and taste. Every meal is a smart balance of carbs, healthy fats, and protein with at least 2 vegetables per meal. Go to factor75.com right now or click the link in the description and use code SuperfastMatt FDG to get 50% off your first Factor box plus free daily greens. That's code SuperfastMatt FDG at factor75.com to get 50% off plus free daily greens.